What if a single building could make the most powerful nation on Earth look like it's still living in the past? China just completed a structure so advanced that American engineers who saw the blueprints reportedly refused to believe it was real. This isn't about a skyscraper or a stadium. This is a facility that combines artificial intelligence, quantum communication networks, and zero-emission energy systems under one roof, fully operational right now. The United States has been planning something similar since 2015. In 2023, a delegation of Western infrastructure analysts visited Shenzhen for a routine technology exchange summit. China finished it first, and the gap between the two isn't years, it's decades. They were shown a facility called the Guangming Science City Integrated Hub, a complex spanning over 1.5 million square meters, built in under 4 years. His conclusion was 3 words: we missed it. One analyst from Germany, Thomas Brecker, submitted a formal report to the European Commission afterward. What Brecker saw inside that building wasn't experimental. It was running. The facility operates on a fully closed-loop energy system. Solar panels embedded directly into the building's exterior skin generate power. Excess energy is stored in solid-state battery banks developed by CATL, and the entire grid is managed by an AI system that predicts energy demand 17 minutes in advance with 96% accuracy. The building has not drawn power from the municipal grid since its soft launch in March of 2023. The Guangming Hub houses China's first fully operational quantum-secured communication network for civilian government use. But the energy system isn't even the most alarming part. Every data packet transmitted inside the facility is encrypted using quantum key distribution, a method that makes interception physically impossible, not just difficult. The United States National Security Agency acknowledged in an internal memo, later leaked in 2024, that it has no current capability to penetrate quantum-encrypted channels of this type. America's own quantum communication infrastructure exists in 6 university laboratories. None of them are connected to each other. Ground was broken in early 2019. The facility was structurally complete by 2021. The construction timeline alone should have triggered alarms in Washington. Full systems integration was finished by late 2022. That is a 4-year build cycle for a structure that incorporates technology the American government hasn't yet agreed on a budget to develop. The U.S. Department of Energy submitted a proposal for a comparable national research facility in 2022. As of 2025, that proposal is still in committee review. Inside the Guangming Hub, over 12,000 researchers work across disciplines that in America are split between dozens of separate institutions in different states, with separate funding streams and no shared data infrastructure. In China, those researchers share a single AI-managed data platform that cross-references findings across departments in real time. A materials scientist working on battery chemistry on floor 7 receives an automated alert if a physicist on floor 23 publishes an internal result that intersects with her work. That kind of institutional integration doesn't exist anywhere in the United States at this scale. The building itself was designed by a Chinese firm, built with Chinese materials, and equipped with Chinese manufactured systems. 0 foreign components in the core infrastructure. This was deliberate. After 2019, when the U.S. imposed export restrictions on advanced semiconductors, China accelerated its domestic alternatives program. The Guangming Hub was the first large-scale proof that the acceleration worked. American officials who were briefed on the facility in late 2023 described their reaction in private as uncomfortable. One senior advisor to the Department of Defense, speaking anonymously to a journalist at The Atlantic, put it plainly, "We assumed we had more time." In February of 2020, Wuhan needed a hospital, not in 6 months, not in 6 weeks, in 10 days. The Chinese government broke ground on Huoshanshan Hospital on January 23rd and admitted the first patients on February 2nd, 10 days later. Together, the two facilities added over 2,500 beds to a city in crisis. A second hospital, Leishanshan, was completed in 16 days. The world watched the construction live on streaming cameras and assumed it was a one-time emergency response. It wasn't. It was a demonstration. The method used to build those hospitals already existed. China had been developing and refining modular prefabricated construction at industrial scale since the early 2010s. The company Broad Group had previously assembled a 15-story hotel in 6 days, using pre-manufactured steel modules bolted together on site. Each module arrived from the factory fully fitted: walls, plumbing, electrical wiring, ventilation, interior finishing, and workers on site did nothing but connect them. No concrete poured on location, no wiring run through walls. The factory did all of it. The site team just assembled. By 2023, this method had evolved into what Chinese engineers call smart modular stacking. Modules are now manufactured with embedded sensors pre-installed. The moment a module is connected to the building's central system, it begins transmitting data: temperature, humidity, structural load, air quality, without any manual setup. A 30-story building assembled this way is fully instrumented from day one of occupancy. In the United States, retrofitting an existing building with a comparable sensor network takes an average of 14 months and costs between $8 and $12 million per structure. The speed records kept breaking. In 2021, a residential tower of 57 stories was completed in Changsha in 19 days. The project used 4,500 pre-manufactured modules. Crews worked in 3 rotating shifts around the clock. The building passed all seismic safety inspections and has been occupied since completion. Structural engineers from Japan who reviewed the project independently confirmed the building met or exceeded local safety codes. It was not a temporary structure. People live there now. American construction operates on a fundamentally different timeline. A comparable 50-story residential building in New York City takes between 4 and 7 years from permit approval to occupancy. The permitting process alone averages 22 months. Labor is sourced from multiple subcontractors who coordinate loosely and often work in sequence rather than simultaneously. The concrete and steel method dominant in American high-rise construction requires curing time that cannot be compressed. China's modular approach bypasses curing entirely because the structural work happens in a controlled factory environment before the module ever reaches the site. The factory output numbers are staggering. Broad Group's manufacturing facility in Hunan province can produce enough modules to assemble 100,000 square meters of finished building space per month. That is roughly the equivalent of a medium-sized American university campus every 30 days. The factory runs continuously, and the modules are shipped by truck, rail, or barge to sites across the country. What made the Wuhan hospitals shocking to outside observers was not the speed itself, it was the quality. Post-construction inspections found no significant structural deficiencies. The HVAC systems in both hospitals were functional from day one. Infection control protocols, negative pressure rooms, isolated ventilation zones were built into the module design before ground was ever broken. These were not temporary field hospitals. They were fully operational medical facilities that happened to be built in under 2 weeks. The United States Federal Emergency Management Agency reviewed the Wuhan construction after the fact and concluded that no American construction firm currently has the prefabrication capacity, the logistics network, or the regulatory framework to replicate that timeline. The report recommended developing domestic modular construction capability as a national resilience priority. That recommendation was filed in 2021. No legislation followed. Songdo, Master, Neom. The world has heard about smart cities for 20 years. Most of them exist as renderings. China's Xiong'an New Area exists as asphalt, steel, fiber optic cable, and 2 million residents. Ground was broken in 2017. By 2024, the city had a functioning underground utility tunnel network stretching over 100 kilometers, a fully operational autonomous vehicle traffic system covering its central district, and a citywide data platform that monitors everything from traffic density to air quality to the structural integrity of bridges in real time. Xiong'an was not built by one company or one ministry. It was built under a unified master plan with a single data architecture designed before the first foundation was poured. Every building in the city's core district is connected to the same municipal AI system. Utility companies, traffic management, emergency services, and environmental monitoring all operate from the same data layer. When a water pipe shows abnormal pressure readings at 3 in the morning, a repair crew receives an automated dispatch before the pipe fails. The city does not wait for residents to report problems. It finds them first. The underground utility corridors are the part that no Western city planner can stop talking about. Instead of burying pipes and cables directly in the ground, the method used in every major American city, Xiong'an built walk-in tunnels beneath its streets. Electricity lines, water pipes, gas lines, fiber optic cables, and heating systems all run through these corridors side by side. Maintenance workers can walk through them upright, identify a fault, and repair it without digging up a single street. In New York City, a broken water main requires excavating the road, rerouting traffic, and a repair timeline measured in days or weeks. In Xiong'an, the equivalent repair takes hours and happens entirely underground with no surface disruption. The autonomous vehicle network in the Central District operates without traffic lights at 17 major intersections. Vehicles communicate directly with the city's traffic management AI, which assigns crossing priority in real time based on traffic density, emergency vehicle location, and pedestrian movement data collected from street-level sensors. The system reduced average intersection wait time to 4 seconds. The national average for a signalized intersection in China is 41 seconds. In Los Angeles, it is 78 seconds. Feeling overwhelmed by China's rapid advancements? Don't worry, you can stay ahead of the game too. Check out playprofi.com for access to all the most popular neural networks with just one subscription. And guess what? If you register today through the link in the description, you'll snag an extra 500 tokens. Xiong'an's building codes require every new structure to meet what China calls a 3-star green building standard, the highest tier in the national rating system. This means each building must generate a portion of its own energy, recycle a minimum percentage of its water, and meet strict insulation and air quality standards. As of 2024, over 60% of completed buildings in Xiong'an's core district exceed the 3-star minimum. The city's average energy consumption per square meter is 31% lower than Beijing's. The facial recognition infrastructure embedded in Xiong'an's public spaces deserves separate attention. Every subway entrance, public building lobby, and major transit hub uses facial recognition for access and payment. A resident can board a subway, pay for lunch, enter a government office, and pick up a package from an automated locker without touching a phone or a card. The system processes over 3 million authentication events per day across the city. Response time per authentication is 0.3 seconds. American urban planners who have visited Xiong'an consistently describe the same experience. They arrive expecting a showpiece, a city built for appearances, not function. They leave having watched the infrastructure work in real time. Pipes that don't flood streets, intersections that move without lights, buildings that generate their own power. The technology in Xiong'an is not experimental. It is the baseline. Every city China builds from this point forward will use Xiong'an as its minimum standard. The United States does not yet have a single city that meets that standard in any one of its components, let alone all of them simultaneously. In 2022, the United States passed the Infrastructure Investment and Jobs Act, $1.2 trillion allocated to repair and upgrade American roads, bridges, rail, and broadband. It was described as the largest infrastructure investment in American history. China spent more than that on infrastructure in 2021 alone, not over a decade, in a single year. The numbers expose a structural problem that money alone cannot fix. The average age of an American bridge is 44 years. There are currently 45,000 bridges in the United States classified as structurally deficient. The American Society of Civil Engineers gives the country's overall infrastructure a grade of C- in its 2021 report card. The same organization estimates that infrastructure deficiencies cost the average American household $3,300 per year in lost productivity, vehicle damage, and higher shipping costs. China builds high-speed rail the way the United States builds highways. As of 2024, China operates 45,000 kilometers of high-speed rail, more than the rest of the world combined. A train from Beijing to Shanghai, a distance of over 1,300 kilometers, takes 4 hours and 18 minutes at speeds up to 350 kilometers per hour. The equivalent American journey, New York to Chicago, covers a similar distance and takes 18 to 22 hours by Amtrak. The fastest scheduled Amtrak service in the country, the Acela on the Northeast Corridor, averages 170 kilometers per hour, roughly half the speed of a standard Chinese high-speed train, on the best track America has. California began planning a high-speed rail line between Los Angeles and San Francisco in 1996. Construction started in 2015, As of 2025, no portion of the line is operational. The project budget has grown from $33 billion to over $128 billion. The completion date has been pushed back to 2033, though independent analysts consider that estimate optimistic. China built its entire Beijing-Shanghai high-speed rail corridor, over 1,300 kilometers of new dedicated track, in 4 years, from 2008 to 2012, at a cost of $32 billion. The comparison in semiconductor manufacturing is equally direct. In 2022, the U.S. CHIPS Act allocated $52 billion to rebuild domestic chip production capacity. Intel, TSMC, and Samsung announced new American fabrication plants. The first of those plants, TSMC's facility in Arizona, was originally scheduled to begin production of advanced chips in 2024. That date slipped to 2025, then to 2026 due to construction delays, permitting issues, and a shortage of workers with the specialized skills needed to operate the equipment. Meanwhile, China's SMIC produced its first 7-nanometer chips in 2022 without access to the advanced lithography machines the U.S. had banned from export. They reverse-engineered a workaround. The permitting problem in the United States is not an accident. It is the accumulated result of decades of environmental review requirements, zoning laws, neighborhood opposition processes, and litigation rights that give individuals and organizations the legal power to delay or block construction projects indefinitely. A solar farm proposed in Nevada in 2017 is still in environmental review in 2025. A transmission line needed to carry wind power from Wyoming to population centers in the Southwest has been in permitting for 11 years. China permitted and built the world's largest hydroelectric dam, the Three Gorges Dam, relocated over 1 million people, and completed the project in 17 years from approval to full operation. None of this means American institutions are incompetent. It means they were designed for a different era, with different priorities, operating at a different pace. The problem is that the era has changed, and the pace has not. China is not competing with the America of 2025. It is competing with the America of 2045, and building infrastructure to match that future right now. China poured more concrete between 2011 and 2013 than the United States poured in the entire 20th century. That single statistic, published by the U.S. Geological Survey and verified by multiple independent sources, stopped conversations at infrastructure conferences across Europe when it first circulated. It is not a metaphor. It is a measured quantity. 6.6 gigatons of cement used by China in those 3 years, compared to 4.5 gigatons used by the United States across 100 years. The scale of Chinese construction output becomes more legible when broken into specific projects. China built over 600 new airports between 2000 and 2024. The United States built 0 large commercial airports in the same period. The last major new commercial airport constructed in America was Denver International, which opened in 1995. In China, airports are being built in cities that most Americans have never heard of, serving populations larger than New York City, connected by high-speed rail lines that were themselves built in the last 15 years. The electricity grid numbers follow the same pattern. China installed more solar power capacity in 2023 than the entire installed solar capacity of the United States as of that same year. In a single calendar year, China added more clean energy generation than America had built across all previous decades combined. The Tengger Desert Solar Park in Inner Mongolia covers over 1,200 square kilometers and generates enough electricity to power a city of 1 million people. It was fully operational by 2016. The largest solar farm in the United States, the Blythe Solar Power Project in California, generates roughly 1/6 of Tenger's output. Wind power tells the same story. China installed 93 gigawatts of new wind capacity in 2023 alone. The total installed wind capacity of the United States, accumulated over more than 30 years of wind energy development, stands at approximately 145 gigawatts. China added 2/3 of that figure in 12 months. The port infrastructure gap is perhaps the most commercially consequential. 7 of the world's 10 busiest container ports by volume are in China. The Port of Shanghai handles over 47 million container units per year. The Port of Los Angeles, the busiest in the United States, handles approximately 10 million. Shanghai's port operates with fully automated container handling equipment across its Yangshan deepwater terminal, which was built on an artificial island connected to the mainland by a 32-kilometer bridge, itself completed in 2005. The automation system at Yangshan processes containers with 0 human operators on the terminal floor. Vehicles, cranes, and logistics are entirely managed by software. The broadband and telecommunications infrastructure gap is closing in China's favor at a pace that telecom analysts describe as irreversible without emergency intervention. China had deployed over 3 million 5G base stations by the end of 2023. The United States had approximately 300,000. China's 5G network covers rural areas, mountain regions, and small towns that American carriers have not yet connected to 4G. Huawei alone manufactures and installs more telecommunications infrastructure per year than all American and European competitors combined. Water infrastructure reveals the longest-term planning gap. China's south-to-north water diversion project is the largest water transfer infrastructure ever built. It moves water from the Yangtze River basin in the south to the dry northern plains, across a distance of over 1,000 kilometers, through 3 separate canal and tunnel routes. The project took 50 years to plan and 15 years to build. The middle route alone, completed in 2014, delivers 12 billion cubic meters of water per year to Beijing and 4 other northern provinces. The United States has not completed a major new water infrastructure project of comparable scale since the Central Arizona Project, which finished construction in 1993. The pattern across every category, concrete, airports, rail, solar, wind, ports, broadband, water, is identical. China is not ahead in one sector. It is ahead in all of them simultaneously, and the lead is measured not in percentage points, but in multiples. The Beijing-Shanghai high-speed rail line required relocating over 240,000 people from the construction corridor. The Chinese government issued relocation notices, paid compensation, and moved every one of those residents within 18 months. Construction began immediately after. No court injunctions, no multi-year environmental litigation, no neighborhood association votes. The project moved from approved plan to operational railway in 4 years because nothing in the legal or political system was designed to slow it down. This is the core structural difference that explains every gap in every category. China's government can make a decision at the national level and implement it at the local level without the decision passing through the dozens of veto points built into American democratic and legal infrastructure. This is not incidental to China's construction speed. It is the entire explanation for it. The Chinese system designates infrastructure as a national priority through a 5-year planning cycle. The current cycle, the 14th, runs from 2021 to 2025 and specifies exact targets. Kilometers of rail to be built, gigawatts of energy to be installed, number of airports to be completed, volume of data infrastructure to be deployed. Every provincial government, every state-owned enterprise, and every relevant ministry receives binding targets derived from the national plan. Failure to meet targets has career consequences for the officials responsible. Meeting them ahead of schedule has the opposite effect. The financing mechanism removes another bottleneck that paralyzes American infrastructure. Chinese state-owned banks lend to state-owned construction enterprises at rates and on timelines that no private capital market would offer. A project that will not generate positive returns for 20 years can still receive full funding because the lending decision is made on strategic grounds, not financial ones. The Three Gorges Dam was not funded because it made economic sense in a conventional sense. It was funded because the state decided the country needed it. American infrastructure must justify itself to bond markets, congressional appropriators, and private investors simultaneously. 3 different audiences with 3 different criteria, all of whom must agree before a shovel enters the ground. The labor system contributes a third factor. China's internal migration system, the hukou, created the conditions for the largest construction workforce in human history. Hundreds of millions of rural workers moved to cities over 3 decades, providing an essentially unlimited supply of construction labor at low cost. This workforce built the physical foundation of modern China. The roads, rail lines, apartment towers, factories, and ports at a speed and scale that would have been impossible with a more constrained labor supply. By 2024, that workforce is shrinking as China's population ages and birth rates fall, which is precisely why China is now automating construction faster than any other country. Chinese construction firms have deployed autonomous bricklaying robots, AI-managed concrete pouring systems, and drone-based site surveying at scale that Western firms are still testing in pilot programs. The automation push is not driven by a desire for technological novelty. It is driven by the mathematical reality that the human labor surplus that built the country between 1980 and 2020 is ending, and the construction output must continue regardless. The engineering education pipeline feeds the entire system. China graduates approximately 1.3 million engineers per year. The United States graduates approximately 160,000. Chinese universities have expanded engineering enrollment every year since 2000, adding capacity specifically in civil, electrical, and software engineering, the three disciplines most directly relevant to infrastructure construction. The result is that China has more engineers working on infrastructure problems than the United States has engineers in total. Speed in Chinese construction also comes from what does not happen. Designs are not revised repeatedly by committee. Suppliers are not changed mid-project due to procurement disputes. Financing is not renegotiated when interest rates shift. The Boston Area Green Line Extension Project, a modest rail expansion adding 4 miles of new track, took 22 years from initial proposal to completion and cost over $3 billion, more than $700 million per mile. The cost overruns were driven almost entirely by contract disputes, design changes, and regulatory compliance requirements that multiplied over 2 decades of stop-and-start progress. China does not have a mechanism that produces that outcome, which is why it doesn't. In 2023, a satellite operated by the Chinese Academy of Sciences transmitted quantum-encrypted data between 2 ground stations separated by over 4,600 kilometers. The transmission was instantaneous, unhackable, and completely outside the reach of any existing American interception technology. The experiment was not announced in advance. Western intelligence agencies learned about it from the published research paper 3 weeks after it happened. The satellite was called Mikius, and it had been in orbit since 2016. For 7 years, Chinese physicists used it to systematically break every distance record for quantum communication, one experiment at a time, while American quantum research remained distributed across university departments with no coordinated national program and no dedicated orbital infrastructure. By the time the 4,600-kilometer transmission was achieved, China had already demonstrated quantum key distribution between Beijing and Vienna, a distance of over 7,600 kilometers in 2017. The American response was a congressional hearing. China's response was to build a larger satellite. The quantum communication network is not the hidden technology. It is the visible edge of something deeper. Beneath the Guangming hub, beneath Xiong'an, beneath the high-speed rail network and the automated ports, China has been building a parallel digital infrastructure that operates on entirely different physical principles than the internet the rest of the world uses. This network, referred to in Chinese government documents as the New Infrastructure Initiative, combines quantum communication backbones, AI-managed routing systems, and a domestic chip architecture that does not depend on any foreign intellectual property. The chip architecture piece became public in an unexpected way. In September of 2023, Huawei released a smartphone called the Mate 60 Pro. Inside it was a 7-nanometer processor called the Kirin 9000S, manufactured entirely by SMIC using equipment that the United States had specifically banned from export to China 3 years earlier. The chip should not have existed. American export controls were designed precisely to prevent China from manufacturing chips at this level of sophistication without access to Dutch ASML lithography machines. SMIC produced it anyway, using a multi-patterning technique that compensated for the equipment limitations through additional processing steps. The chip was not as efficient as chips produced by TSMC using unrestricted equipment, but it worked, and it was entirely Chinese. The reaction inside the U.S. Commerce Department, according to reporting by Bloomberg, was described as a 5-alarm moment. The export control strategy had been predicated on the assumption that China could not work around the lithography bottleneck for at least 5 to 7 more years. That assumption was wrong by approximately 4 years. Within weeks of the Mate 60 Pro release, the Commerce Department convened an emergency review of the entire semiconductor export control framework. The review concluded that the existing controls were insufficient but offered no clear alternative, because the alternative, preventing China from accessing all advanced manufacturing technology, was already years too late. The military construction dimension of China's building surge is the part that American defense analysts discuss in the most urgent terms. China has built, in the South China Sea, a series of artificial islands equipped with military-grade radar installations, missile batteries, hardened aircraft hangars, and deep-water port facilities capable of servicing nuclear submarines. The largest of these installations, on Mischief Reef and Fiery Cross Reef, were built in under 3 years on features that were previously submerged reefs with no above-water surface area. China dredged sand from the ocean floor, created land where there was none, and installed permanent military infrastructure on it before international legal challenges could be resolved. By the time the Permanent Court of Arbitration ruled the construction illegal in 2016, the islands were already built, armed, and operational. The ruling changed nothing on the ground because there was now ground where before there had been only water. The technology embedded in those islands includes over-the-horizon radar systems capable of tracking surface ships and aircraft across the entire South China Sea, electronic warfare installations that can jam communications across a wide frequency band, and runway infrastructure capable of operating China's most advanced fighter aircraft. All of it was built using the same modular construction techniques, the same prefabrication methods, the same rapid deployment logistics that built the Wuhan hospitals and the Xiong'an utility tunnels. The construction capability is not separate from the military capability. It is the military capability. What China has built is not a collection of impressive projects. It is a system, an integrated, self-reinforcing infrastructure of physical construction, digital communication, energy generation, and manufacturing capacity that compounds on itself with every passing year. Each new facility produces the engineers, the data, and the manufactured components that make the next facility faster and cheaper to build. The Guangming Hub trains researchers who design better modular systems. The better modular systems build the next Guangming Hub in half the time. The United States is not behind in a race. It is watching a different race, on a different track, moving in a direction it has not yet fully mapped. The question at the start was simple. How does a single building make the most powerful nation on Earth look a century behind? The Guangming Science City Integrated Hub is the answer, but not because of what it contains, because of what it represents. It is the physical product of a system that has been building toward this moment for 40 years without interruption, without changing direction, and without waiting for anyone's permission. In 1978, China's GDP per capita was lower than that of Mali. 46 years later, China manufactures more goods than the United States and Germany combined, operates the world's largest infrastructure network, and has sent quantum-encrypted signals across distances that American technology cannot match or intercept. That trajectory, from subsistence to dominance in less than 2 human lifetimes, has no precedent in recorded economic history. The gap is not closing in America's favor in any measurable category. High-speed rail. China has 45,000 kilometers. America has 0 dedicated high-speed track. Quantum communication. China has an operational satellite network. America has laboratory experiments. Modular construction. China builds 50-story towers in 19 days. America's fastest comparable project takes years. 5G infrastructure. China has 10 times more base stations than the United States. Engineer graduates per year. China produces 8 times more than America. Semiconductor independence. China manufactures advanced chips without foreign equipment. America's most advanced domestic fab is still under construction. The Guangming Hub's proposal is still in committee review in Washington, not a comparable facility. The proposal to study whether such a facility should be built. The gap between those two positions, one country operating a facility, another country reviewing a proposal to consider building one, is not a gap of technology or money. It is a gap of institutional velocity. China's system makes decisions and executes them. America's system debates decisions and litigates them. Both approaches reflect genuine values. Only one of them builds 45,000 kilometers of rail. The final fact that reframes everything else is this: China is not doing any of this at peak capacity. The construction surge of the 2010s was built on a workforce and a capital base that are both now contracting. Birth rates have fallen. The rural labor surplus is exhausted. Debt levels in Chinese municipal governments are high enough to concern even Chinese economists. And yet, even as these structural pressures accumulate, China is automating its construction industry faster than any country in history, deploying AI management systems across its infrastructure network, and training the next generation of engineers at a scale that ensures the pipeline does not empty. America's advantage has always been innovation, the ability to produce breakthrough technologies that change the rules of the competition. the semiconductor, the internet, the smartphone, the GPS system, all American inventions that defined the infrastructure of the modern world. The question for the next 20 years is whether that innovation advantage can generate new rules fast enough to matter, or whether the game being played now, the game of physical infrastructure, manufacturing scale and deployment speed, is one where the rules are already set and the scoreboard already shows who is winning. Thomas Brecker, the German analyst who submitted a 3-word report to the European Commission after visiting Guangming, was asked in a follow-up interview what he meant by, "we missed it." He said the "we" was not just Europe. He meant every country that spent the last 20 years assuming China was catching up. It is not catching up, it arrived. The building is built, the trains are running, the satellites are transmitting. The question is no longer whether China can compete with American infrastructure. The question is whether America can compete with China's.